Welcome back! Today, we're diving into how transistors work as switches. So far, we've used mechanical switches and push buttons to turn circuits on and off. But what if you want to control a high-power device like a motor or a light bulb? Or trigger a switch automatically using a sensor or some code? That's where transistors come in. They're electronic switches that let us control large currents using small signals. No mechanical movement required at all. So, what exactly is a transistor? A transistor is a semiconductor device that acts like a switch or amplifier. Unlike physical switches, it uses electrical signals to control current flow, instantly and silently. Transistors come in many different shapes and sizes. However, there are two main types. We have the bipolar junction transistor and the field effect transistor. We'll primarily be taking a look at the bipolar junction transistor though. And in our kit, we have an NPN and a PNP transistor. They look pretty much the same. So to identify your transistor, you'll see that they have text on the back. This is the part number which we can use to find the datasheet, which tells you all the relevant information related to the component. Now, let's talk schematics. With a transistor, we have 3 pins, labeled emitter, base, and collector. For the transistors with the flat backs, the left pin is commonly the emitter, the middle is the base, and the right is the collector. Not always though, so make sure you check out that datasheet. Transistors have specific symbols in circuit diagrams. For NPN transistors, you'll see 3 terminals: collector at the top, base at the side, and emitter at the bottom. In an NPN transistor, the current flows from the collector to the emitter when you apply a high voltage at the base. The arrow on the emitter points out. Think NPN not pointing in. For PNP transistors, the arrow points in, towards the base. Additionally, in a circuit diagram, we have the emitter on top, base at the middle, and the collector at the bottom. And the current flows from the emitter to the collector when you apply a low voltage at the base, the opposite of the NPN transistor. The easy way to remember is to look at the arrows on the diagrams. They either point into the base or out of the base. Let's look at why we use transistors. We know if we connect a light to a battery, the light will turn on. Previously, we used a switch or a button to control when the light is on and off. We can eliminate the need for a person with a transistor. By default, when connected, the transistor blocks current so the light is off. Say we're using an NPN transistor. If we apply a small voltage at the base pin in the middle, current now flows. When the base receives a voltage of around 0.6 to 0.7 volts higher than the emitter, current flows. You could also use a PNP transistor. This time though, you connect the emitter to the positive terminal of the battery, and current flows when the base receives a voltage that's 0.6 to 0.7 volts lower than the emitter. The base is connected to ground, and so current flows from the emitter to the collector. We can use a sensor to control this activation. So we could use an LDR and a transistor and make a nightlight that turns on when it gets dark and automate this. Let's compare NPN and PNP transistors. With a PNP transistor, current flows from collector to emitter, and the base needs a high signal to turn on. The arrow on the symbol points out, and it behaves like a normally open button. With PNP on the other hand, current flows from the emitter to the collector, and the base needs a low signal to turn on. If you're using an Arduino or microcontroller, NPNs are usually easier because they work directly with digital logic. If it's high, it's on, and if it's low, it's off. How do you know which one to use? If you want your circuit to be on when a signal goes high, then use an NPN. If you need your circuit on when a signal goes low, then use a PNP transistor. Alright, let's wrap it up. Transistors are electronic switches. They control big currents with small signals. NPNs turn on when the base is high, and PNPs turn on when the base is low. Remember, NPN arrow points out, PNP arrow points in. You'll use them in automation, power control, microcontroller circuits, pretty much everywhere. Next up, our hands-on lab. We'll use light-dependent resistors with a transistor to build a light-activated switch. You'll see how sensors and transistors work super well together to make smart decisions. And don't forget, post your circuits and tag us on social at Horizon Robotics Lab. See you on the next one. If you like what you've seen so far, you should visit our website and check out our electronics and coding kit. It comes with all the videos, all the lessons, all the code, all the labs, and all the project files. So yeah, link in the description and happy learning.